Hi everyone, welcome to my class. Today we will see some of the important question and answers in the chapter electricity. So we will see about the difference in resistors in series and parallel. And we know what is meant by resistors in series. That is, if it is connected like this, that is 1-to-1 combination is there, we call it as resistance in series. At the same time, all the resistance are connected with a common point. Then we call it as resistors connected in parallel. So we are going to see the difference between the both. The first difference is the current through each resistance is same. So for example, let me take this as R1 and this as R2. Let me connect one more resistance also. Let it be R3. So in all the three cases, the current will be same. That is, say for example, I, the current through all the resistance will be same. If you are taking the resistance in parallel, the current will not be same in all the cases. The current will be different in R1, R2 and R3. In all the cases, the current will be different, and also it is to be noted that here the I is inversely proportional to the resistance. And the second difference is the potential difference across each resistor is not the same. So if you are taking this one, that is the potential difference will not be same. It will be different for different resistors, that is R1 and R2 and R3. That is, it is going to vary like V1, V2 and V3. But if you are taking the resistance in parallel, in this case, the potential difference across each resistor will be same. That is, say for example, V. The third difference will be the equivalent resistance is equal to sum of the individual resistance. That is, if I am summing up all the three resistances, that will be the total resistance value. So if I am taking the parallel combination, the equivalent resistance will be equal to sum of the reciprocal of the individual resistance. That is 1 by R1 plus 1 by R2 plus 1 by R3. So here what I can say about the total resistance, R is equal to R1 plus R2 plus R3. On the other hand, in case of the resistors in series, this will be the resultant resistance. And the last and the final point we are going to see is the equivalent resistance is larger than the largest individual resistance. Say for example, here as we have chosen R1 and R2, I am going to give some values for this. Let the first resistance R1 carries 3 ohm and the second resistance R2 carries 10 ohm and the third resistance R3 carries 4 ohm. So which is the largest resistance here? The 10 ohm. So if I am calculating the total resistance, it is going to be larger than the largest individual resistance. That is, it will be more than 10 ohm. That is the meaning of the statement. And if you are taking the resistors in parallel, the equal resistance is less than the smallest individual resistance. The same resistance, if I am connecting in parallel like this, and this is going to be 3 ohm, this is 10 ohm and 4 ohm. The total resistance, if I am finding, it will be smallest than the smallest individual resistance. So in this case, which is the smallest resistance, we know that it is 3 ohm. So the total resistance will be lesser than the 3 ohm. So this will be useful in doing the one word problems also. So these are all the major differences between resistors in series and parallel. Thank you for listening.